Good morning and welcome back to Chemistry Week 4 of the 2020 fourth marking period. Today we're going to be learning something called determining the limiting reactant. I'm dressed up a little bit today. I just got done delivering yard signs to all the seniors. So I was wearing my gown and driving around and putting out yard signs and delivering caps and gowns. So that was a lot of fun to see some of those seniors this morning. But anyway, so I didn't have time to go home and change, so I'm just going to shoot it with my wonderful tie on, so it's going to be a little more professional today, which is good because today's topic is kind of big. It's a concept I think you guys can understand in that when you're determining the limiting reactant, what you're trying to do is figure out which one of your ingredients is going to run out first. So in the scenario I've given you, we have aluminum nitrate and calcium oxide reacting to form calcium nitrate and aluminum oxide. If you were to be given a random amount of each one, 181.1 grams of this and 102.1 grams of that, we just pour it onto a table and say, all right, how much of the other stuff are we going to make? How much of each one of those can we make? So imagine this. Imagine you're out by a campfire and you're making s'mores. And if you want to make a s'more, you're going to need 2 graham crackers, you're going to need 1 marshmallow, and 1 piece of chocolate. So 2, 1, and 1. That's kind of like our moles, in that those are the ratios that you go together when you make a s'more, 2, 1, and 1. So if you had 10 graham crackers, you had 20 marshmallows, you had 30 pieces of chocolate, how many s'mores could you make? 10 graham crackers, 20 marshmallows, 30 pieces of chocolate. Well, if the ratio is 2 to 1 to 1, and I only have 10 graham crackers, then the graham crackers are going to run out first. So I'm going to make 5 s'mores, and I'm going to have a lot of marshmallows, I'm going to have a lot of chocolate left over. So the graham crackers were the limiting reactant. They were the thing that ran out first. So what we're trying to determine here in today's reaction here is which one of these, is it the aluminum nitrate or the calcium oxide, which winds up being our limiting reactant. So in order to do that, the first step we have to do is figure out the molar mass of all the players. So we've done molar masses. I'm going to set some stuff up here just to make this video a little bit shorter. I'm going to set some things up on the board, and then I'll pick this back up and explain what I've done. So give me just a second. Okay. So what I've done is I've broken down each one of the elements here, or each one of the compounds. So aluminum nitrate is made up of aluminum, nitrogen, and oxygen. And in this compound, we have 1 aluminum. That 3 tells me that there's 3 nitrogens, and then 3 times 3 tells me that I have 9 oxygens. So total, I have 1 aluminum, 3 nitrogens, and I have 9 oxygens. I did that for each one of these. So calcium oxide is 1 and 1. Calcium nitrate, I have 1 calcium, I have 2 nitrogens, and 6 oxygens, 1, 2, and 6. And then aluminum oxide, I've got 2 aluminums, and I've got 3 oxygens, so 2 and 3. So that's how many of each atom I have. Now I got to figure out what their molar masses are. So I use my handy dandy periodic table, and I look up their masses from the periodic table, and I round it to the nearest 10th, because that's what we've been doing just to make sure our numbers are doable. Okay, so aluminum is element number 13, has a mass of 26.98, so I'm going to round that to 27. Nitrogen, I know off the top of my head, is 14. I also know the oxygens is 16, okay? Calcium, element number 20, 40.078, so I'm going to round that to 40.1. And oxygens, we already know, was 16. Calcium over here, it's the same as it was over here, 40.1. Nitrogens are still 14. Oxygens are 16. Aluminum, we figured out over here, was 27. And oxygens, again, are 16. Now that I've got that set up, I can then calculate what the masses are, simply by multiplying these and then adding up the totals. Okay, so I'm going to do that real quick in my calculator. So sorry to bore you. 1 times 27, that's 27. 3 times 14, 42. And 9 times 16 is 144. Add that up. 213 grams per mole. All right. One of these and one of these, we can just add that straight up. So this is going to be 56.1. 40.1. This is going to be 28. 16 times 6 is 96. Add those up. So 96 plus 28 plus 40.1 type that in wrong. 40.1, not 4.1. 40.1 plus 28 plus 96 is 164.1. And then over here, 2 times 27, that is 54. 3 times 16 is 48. 102. Okay, so what we've just calculated is the molar mass of all the reactants and all the products. Now what we have to do is figure out, using the ratios of how everything goes together, which one of these is the limiting reactant. So I need to turn the grams that I was given, okay, into a number of moles by dividing by the molar mass. So what I'm going to do real quick to clean up my board, because I need more room, I'm going to move each one of these totals above so I can use them later, so I can reference them, but I don't have enough room on my board. So give me one more minute. I'm going to pause and I'll be right back. Okay. So as I said I was going to do, I took each one of our molar masses and I just moved it up over the top of each one so I can use them. And now I take the original numbers that I was given, 181.1 grams of aluminum nitrate and 102.1 grams of calcium oxide. And I need to figure out how many moles of each of that I have. So if I use my stoichiometry flowchart, I want to go from a mass of something to the moles of something. And to do that, I'm going to divide by the molar mass. So if I'm dividing by the molar mass, the top number here, these are our givens. So these are always going to be 1. It's an automatic 1 mole, 1 mole. And then this number is the number we just calculated. So for aluminum nitrate, it's 213 grams. And for calcium oxide, it was 56.1. Okay, so now grab your calculator and divide those two problems out. So 181.1 divided by 213 is 0.85. 0.85 moles. That's how much we actually have. And of the calcium oxide, 102.1 divided by 56.1. Oh, great. Really, I'm not moving around enough in here. Lighting bill. There you go. 1.82. So 1.82 moles. That's how much each of them I have. Now, to figure out which one runs out, you need to do a mole ratio on either one of these. It doesn't matter. One of these we have to convert to the other. I need to know how much do I have versus how much do I need, because the ratio is always 2 moles of this for every 3 moles of this, just like it's 2 graham crackers for 1 marshmallow. So I need to know which one of these runs out first. So pick one, doesn't matter which one, and we're going to do a mole ratio on it. Okay, so let's pick the top one here, this guy. So we're going to do aluminum nitrate. So if I'm in moles of aluminum nitrate, what I want to do is I want to convert to moles of CaO to see how much of this, if I have 0.85 moles of it, is that going to be enough, or is this going to be too much? Which one runs out first? So here's how you do it. Mole ratio, okay? So I'm in moles of aluminum nitrate. I'm trying to find out moles of CaO. How much am I going to need? Well, it's always a 2 to 3 ratio. So I in moles of aluminum nitrate, so I'm going to put 2 moles down here, because moles of aluminum nitrate will cancel moles of aluminum nitrate, and this will be moles of what we're trying to find. 3 moles, okay? So now I grab my calculator. It's back up here. There we go. So I'm going to take my answer, which was 0.85. I'm going to multiply it by 3 and then divide it by 2. So 0.85 times 3, enter, divided by 2, enter, is 1.28. 1.28 moles. So think of another analogy. Before I explain what you have here, here's what I want to understand. Imagine you're going into a store and you want to buy something and the cost of it is $3. In your pocket, you have a $5 bill. Do you have enough money to purchase it? Yes, you do. You'll actually have $2 left over. Let's say your friend goes in and wants to purchase the same thing for $3, only they have $2 in their pocket. They don't have enough, right? So the idea of limiting reactant is, what do I have present? What's in my wallet? And what is the total cost? okay? So here's what I want you to understand. When you weigh out 102.1 grams of calcium oxide, you divide by its molar mass, you are looking at 1.82 moles of calcium oxide. If we go for every 2 moles of this, we need 3 moles of this. So for every 0.85 moles of aluminum nitrate, I'm going to need 1.28. So this is what you have. This is what I need. This is what I have. Okay? I need $1.28. That's the cost. I have $1.82. Do I have more than I need? Yes, I have more than I need. So what that tells me is that this is going to be an excess. All right, this is not the limiting reactant. We're going to have an extra left over. So if I subtract these two numbers, it'll tell you exactly how much per mole I would have left over. So when I determine who the limiting reactant is, I look at these and say, all right, what do I need and what do I have? My need is 1.28. I have 1.82. Since my have is bigger than my need, then this is the one that will be excess or leftover. So this is going to be the marshmallows and the chocolate. So that tells me that the aluminum nitrate he's going to be the limiting reactant. He's the one that's going to run off first. He was our graham crackers in our scenario. Now that I know that, now I can safely figure out and I can accurately figure out how much of the other two things I'm going to make. Okay, so I'm already, if we follow our flow chart, we've gone from mass of the given. We divided by a molar mass. We now have moles of the given. I know I have 0.85 moles of our given. Now if I want to figure out how much of this and how much of this do I make in grams, then I'm going to have to go from blue to blue and then blue to yellow. So I need to do two more brackets, one here and one here. So we're going to take this number. This is going to be where we start now. So instead of starting all the way back to here, you've already done that calculation once. If you want to do 3 brackets, you could. You're just going to doing something over that you've already done. So we can just start with 0.85 moles. I'm going to do that down here, and I'll just do one at a time for sake of space. Let's say I wanted to figure out this guy. Let's just say we want to figure out calcium nitrate. So if I want to figure out calcium nitrate, I'm going to start with the moles that I have. Since I'm already in moles, I don't have to do 3 brackets. I'm only going to do 2. All right. And we're going to end in grams of CaNO3, 2. That's what we want to figure out, is how many grams of that are we going to have left at the end of our whole problem here, okay? Since our first bracket is already done, this is the mole ratio, and it's always going to be the unknown over the given. Well, we were given aluminum nitrate. Aluminum nitrate has 2 moles, so this is going to be 2 moles. We're trying to find out calcium nitrate. Well, calcium nitrate was a 3. If I stop right there, I'm now in moles of calcium nitrate, but I want to go to grams. So the last thing to do here is multiply by the molar mass of calcium nitrate. We did that problem earlier to save some time, so it's 164.1. So 164.1 grams in 1 mole. Now that I've got this set up, moles cancels moles, moles cancels moles, grams is your answer. So you grab your calculator again, and we're going to start with the 0.85. We're going to multiply by 3 like we did. We're going to divide by 2, which is 1.275 or 1.28. And now we're going to multiply that by the molar mass. So times 164.1. And our answer is 209.2. 209.2 grams of calcium nitrate is going to be made in this reaction. If I wanted to figure out the moles of aluminum oxide, all right, I can do that. I'm just going to take this out since we don't need it, just so I can have some room. Because we've already done that calculation, we know that this was the limiting reactant, so really I'm never going to use this number. I only needed this number to figure out what I have and what I need, but I'm never going to use that 1.82 in any of my calculations, so I can just get rid of all this now. So I'll pull him out. And now let's say I wanted to figure out this guy. All right, aluminum oxide. So if I want to figure him out, we start with the limiting reactant, okay, which we figured that out. So we start with 0.85 moles of AlNO3, mole ratio, multiplied by molar mass, gives me grams of Al2O3. All right, since I'm already in moles of the given, I need to go to my mole ratio. So unknown over given. Unknown is aluminum oxide. We used 1 mole of aluminum oxide. So my ratio here now is going to be 1 mole over 2 moles. All right, so that's my mole ratio. Unknown over given, 1 over 2. And then we multiply by the molar mass, which we figured out earlier, save some time, 102. 102 grams and 1 mole. Now do your calculator again. So we start back at 0.85, multiply it by 1, or just don't, because it's 1. Divide by 2, and then multiply times 102. We are going to make 43.4 grams of aluminum oxide. Okay, I know that's a lot. You're probably going to have to watch this more than once to see which step I did in which order, but it is very methodical. You're just doing, but the math, really all you're doing, the math is multiplying and dividing. That's all you're doing. There's no algebra here. There's nothing too tricky. Determining the limiting reactant, which of the ingredients runs out first when you are given 2 random amounts, as we did, 181 and 102. We needed to know exactly how much that stuff, which one ran out first. So that is determining the limiting reactant. I'll have some problems for you. This is the only video this week because this topic is somewhat challenging. So I'm going to give you some practice problems, and I wish you good luck and hope everybody is doing well and staying healthy.